Feeling okay about it? Okay, we are going to have a quiz tomorrow. And it's going to be on a lot of this stuff. So I want to make sure we feel comfortable with everything we've done. I will indeed read the word problems on there, but you'll have to come up with the problem set that we have. What kind of questions can I answer for you? Yeah.
9.
Number 9. You got it. Is that the one? Cool. All right, so first thing I want to do, Costa, you got something in your ear.
Oh, really?
Do you feel comfortable with that? Okay. These are like terms, so I'll go ahead and combine those. Subtract 1. I know I didn't talk through it, but do you feel okay about that?
Yeah.
Okay. Divide each side by 4. That's not negative, so the sign will not flip. Okay, so I forgot what the instruction said on here. Did it say write in interval notation? Solve. Okay, so we solve for the inequality, and then the interval notation, being the x is on the left side, the arrow points the direction we're going. So the arrow is pointing to go to negative infinity. So we do interval notation from left to right. So negative infinity to negative 2, rounded bracket, soft bracket on the 2 because we didn't have an equal sign. What else did you see? Any other questions? All right, well, let's take a look at some discrete data. Okay? And I'm just going to arbitrarily make up problems. Just want to make sure you feel good. Then we're going to go over continuous data. We have less than 10 puppies left. So we have less than 10 puppies left. So do we have 10 puppies?
No.
No. But we're going to use the 10. How many puppies can we go down to? 0. Okay, can we get to 0 puppies? But we have less than 10 puppies left. So that's our interval notation. This is discrete because we have something that we're counting. We have 1 puppy, 2 puppy. Did they have it or were they closed? Or? Oh, okay. I'll let you take pictures of my pages starting today. Is that okay? And then hopefully we'll get it in. So discrete data means that we can definitely count it. We're not counting up to or counting down from. And Key, I figured you had your homework, so I give you points for it. Yep, giddy up. All right, so other things that are discrete data. Money. But where students get confused with money is money can have decimals. So let's say I have at least $5.26. Okay, I have at least $5.26 in my pocket. So could I have $5.26 in my pocket, or does it have to be more? I can indeed. I can have $5.26. Now, it's kind of funny to say we have infinite money, but theoretically we're counting up. Okay, can we really have infinite money? No, we can't get there. It'd be kind of fun to try and spend infinite money. Go into a store, buy everything, give it away. Go into the next store, do the same thing, give it away. I don't know. Who knows? Go to the car dealership, buy all the cars on the lot, give them all away. Can you imagine being a salesman? You here to buy a car? Yeah, I'll buy all of them right now. What? So money is discrete, even though we have decimals, because it doesn't have decimals that go beyond 2 decimal places. Okay? So people in an elevator would be discrete. People in a restaurant would be discrete. People in a classroom would be discrete. Okay? So the difference between discrete and continuous is like a temperature. Okay? So if you go home and you turn your oven on, if you open your oven, it hasn't been on all day, the inside of your oven is about the same temperature it is as the rest of the house or the rest of the room. Agreed? But if I turn my temperature up to 350 because I want to cook something, it doesn't go from 0 to 350, or it doesn't go to whatever room temperature is to 350. It goes through all the temperatures. It rises up. Okay? So that would be continuous data because we have all those decimals that exist. Weight, okay, a certain mass is going to be continuous data. And again, think about if you go on to a diet and you lose some weight, or perhaps you decided this week I'm just going to eat salads. I don't know why you would, but let's just say you did. If you drop weight, your body doesn't say, oh, it's down a pound. It's down another pound. Okay, your scale might read that, but your mass of your body is decreasing. It's going through all the decimals and fractions to get to the next lower number. Or if you go the opposite end, saying, I ate McDonald's all week, I don't know why I put 5 pounds on. But your mass of your body, your weight, would be continuous data. Okay? So is there any questions between discrete and continuous that I can help you on any different way? Okay, so the quiz that we will see tomorrow, if you had a problem like this, so things I'm looking for, this might say put on number line, which would mean I need to solve this. Okay, so that's the inequality. On a number line, it would look like this. So I have 0 someplace on the number line, and to the right of it, I have 2. So I would be looking to make sure, do you have the solid dot? That'd be worth a point. Did it shade the right way? That's another point. Was this solved? Actually, that'd be 2 points. Okay, so that right there would be a 4-point problem. So, friends, I just want you to be aware, just on the grading. If this was here and you gave me just this, you're going to get 2 of the 4 points because I want to make sure that you had it solved. Okay, if you don't solve it and you just have it on the number line, even though the number line is correct, that's great, but I want to see the thought process. I want to see the inequality. Okay, we also might ask for this to be on interval notation. Interval. So this would be, hey, I'm going to negative infinity, going to 2, hard bracket. Well, that's a point. That's a point. And between both of those is another point. So if I asked you to have it on a number line and also have interval notation, start counting the points up what this problem would be worth. 1, 2, 3, 4, 5, 6, 7-point problem right there. Okay? But if you start leaving stuff out, it's like, oh, I did it all in my head. I can't grade what's there. You got to put it down paper, please. Okay? So, do we know the difference between an open dot and a closed dot? An open dot on a number line would look like this. So we call that, I don't know, call it 7 or something like that. So this would be 7 is greater than infinity. Okay, when does an open dot happen? You have this sign or this sign. Okay, that creates an open dot. Infinity always has a soft bracket open dot on the number, or an inequality sign that does not have an equal sign creates an open dot. A closed dot would be if I had this or this on the number line. Hi. Gotcha. Yeah. A closed dot, let's do the same type of thing. Let's say that's a 7. If it's a closed dot, you color it in. And then you could show it going whatever direction you want. So soft bracket negative infinity, because that's where the left goes to 7, hard bracket. So closed dot, inequality, you have the equal sign. You have a square bracket because of the equal sign. And again, the infinity, no matter what, will always have the infinity will always have a soft bracket, a parenthesis. Okay? All right. So, yeah.
Can you go over more again how, like, the difference between a number having a hard bracket and a soft bracket?
Yeah. So let's work out a problem. Let's say I had so without even starting the problem, I know that I would have a solid dot if it was asking to plot on a number line. And I also know that this would have a hard bracket at the number. Now, the reason why I know both of those without even working the problem is that equal sign. Okay? Now, again, if it goes to infinity, the infinity will always have a soft bracket. But the number itself, when you solve it, would have the hard bracket. So if I were to work out this problem, those cancel. Sign stays as is. 7 subtract 11, I believe, is negative 4. I think I did that right. And then divide by 5. So I have a hard bracket at negative 4/5. I want values to the right of 4/5, which means it goes to infinity. Infinity has that. If it was a graphing problem, I would just have to say, okay, let's say I have 0 here, negative 4/5 here. This would have a solid dot shading this way. So these two things go hand in hand with each other. The interval notation is just a neater way rather than having a graph showing the direction. Okay, did I answer your question? Cool. What else do you have for me, my friends? Okay, so what... Okay, flipping problem versus flipping inequality. Let's say I had a problem like this. I had a problem like that and I wanted to solve it. So this is going to be one where I want to flip the problem. I'm flipping the whole thing over, not because I'm multiplying or dividing by a negative, but I'm flipping the whole thing over because I want the x, or the variable, to be on the left side. If my variable is on the left side, then this says direction to shade or go. Okay? So this would, as interval notation, go to negative infinity up to -1, hard bracket on the -1 because I have that. Okay, so there are times you might solve a problem and you wind up, you have your x or whatever letter you're solving for is on the right side. Once that happens, just take the whole thing and flip it over. The sign didn't change directions because you multiplied or divided by a negative. It switched directions because I want to have the letter first. If the letter's first, that is a nice mnemonic to look at, saying x to the left of -1 is basically what it says. X is less than or equal to -1. So again, this arrow here is pointing the direction we go. The number line that way goes to negative infinity. Okay? So that's if I have to flip the problem. Okay, so that's flipping the problem. Well, what if it was flip the inequality? This is going to be done when you have to multiply or divide by a negative number to get letter alone. So you could have something like this. Or you could have something like this. So both of those problems are going to result in the sign flipping over. They result in the sign flipping over because I have to get, on this one, I'd multiply both sides by -8. Those cancel. This flips directions. Okay, so note the direction changed because I multiplied or divided. If the number I'm multiplying or dividing by is negative, the inequality sign flips over. If it was already negative on one side and you just had to divide by just a number, and that number you're dividing or multiplying by is not negative, second problem is done this way. I have to divide each side by -3. Okay, and then the answers to both of these, this would go from negative infinity to -80, soft bracket, because I don't have an equal sign. This one would be from -4, hard bracket, to infinity. And again, the hard bracket is dictated because we have a negative sign versus, or it has a equal sign rather than just a greater than or less than sign. Okay? All right, so I want to give you guys the opportunity to work on this. If you don't have your book, you can come take a picture of my page. But we're going to work on page 75, 76, and we're going to do 1 through 17. And you have the rest of the period to work on it. Ask me if you need help. If you need a picture of my page, come get a picture.